Another type of optimization problem that you're going to encounter are those involving speed, time, and distance. So it's very useful to think about how speed and distance and time are related. So I know that distance is velocity times time. That's the one I remember, and then I can derive either of these. I also know that if I have a formula for distance, taking the derivative can lead me towards finding the speed or the velocity. Generally, when I think about velocity, I'm thinking about speed with a direction. So it's important that I know north, south, west, and east. I always remember this, that it spells out we. I'm sure you already know these, but it's important. So if I started at an initial position of x naught, I don't actually know if that's positive or negative, but if I'm heading east, then I would be going this way. The magnitude would give me my speed. So this whole vector, of course, represents my velocity. This one, I've got y naught heading south. And again, magnitude gives me how fast I'm going. So if we look at this, we've got an airplane flying east at 300 kilometers per hour. So that's my speed. I pass over Bangkok 10 minutes before a second plane flying south at 420 kilometers per hour passes the same point. So if I think of this point, I've got my one plane flying east. And if I want to think about how far it's traveled, because I want to know at what time is the distance a minimum. So if I'm going 300 kilometers per hour, then this distance is going to be given by 300 t, or if I want to let time be how long this plane has flown, then I could have t plus 1/6. Notice this is kilometers per hour. I had 10 minutes, and so 10 minutes is 1/6 of an hour. Then if I think about my other plane flying south, so it passed the same point, and it now travels, this is how far I have traveled, my speed times my time. So now if I want to know the distance between them, well, here's my distance between them. If I let that be d, I know from Pythagorean theorem, d squared is the same as 420t squared plus 300 times t plus 1/6 quantity squared. Now I could square root this, take the derivative, or I could leave it like this and use implicit differentiation. So I'm differentiating with respect to t, so the derivative of this left side is going to be 2d, so I'm using chain rule, times dd dt, so that's what I'm looking for. I want this derivative to be 0. That's going to be equal to, I could either expand this or again use chain rule. So if I expand it, then I've got 420 squared, which is a very big number. And then I would multiply that by 2. All right, so we've got 352,800. And I multiplied it by 2 because if I expanded this, then I would have had that first number, the, what was it, 176,400 t squared. So I'm going to do multiply it by 2 when I take the derivative, and then it will just be t. This one I'm definitely going to use chain rule, plus 2 times 300 t plus 1/6. Now that's to the first power. Derivative of the inside is going to be 300. And then I want to figure out my distance so that at what time is the distance between them a minimum. So I want my derivative to be equal to 0. So this is going to be equal to 0 when this section is equal to 0. Notice I could isolate this, divide by the 2d, but then if I set it equal to 0, it's still the numerator that has to be equal to 0. So solving this, I'm going to have that number, my 352,800 plus 2 times 300 squared. All right, and so that's going to be, well, I should have. Okay, 532,800. And then if I multiply all of this by my 1/6, then I will have, so that's going to be my t's. I feel like I'm going to end up with a negative. Oh well, let's keep going with it anyhow. So expanding this, I would end up with, I think that's going to be, well, let's see, 3528 plus 2 times 300 squared. All right, this is going to be my t coefficient. And then when I expand my constants, I'm going to have 300 times 1/6 is 50, 100, that's going to be 300,000. No, that's going to be, yeah, 50, 100, 30,000. So what did I say? 532,800 t equals negative, so 300,000, no, 30,000? Goodness gracious. This is why I'm not going to do math in my head when I have my calculator. Divide by 6 times 600 from the 2 and the 300. All right, 30,000. I was right. Great. And now I'm going to divide that by this number, and I'm going to simplify the fraction, and I get 25 over 444, but negative 25 over 444. So really what this implies is that the time that the distance is the shortest between them is actually when my first southbound plane hasn't yet passed that spot in Bangkok. And I don't know whether this is going to be positive or not. I need to figure out whether that 1/6 minus this number is positive or negative. However, I seem to recall that in your notes, I got a different value. I got 49 over 444. Not, so let's see, together, is that going to make my same number? So 352,800. Oh, I got 58. Oh, because I used the 420. All right, but the time should have, let's see. So if we have my value here as my, that should end up being the same as this t value. So if I do my 49 over 444 minus 1/6 and make that into a fraction, we get the same number. Okay, so it does agree. So if I had plugged this in, I would have found my time to be the amount that my plane 2 had been traveling would end up being a negative number. And in that situation, with the negative number, it means that since this value is positive, the triangle I end up having is this one up here. So this value is still positive. This plane hasn't yet reached that spot is really what it means. So my distance between my two planes ends up being found with this triangle. And knowing that my t is this value just means that this plane hasn't yet reached that point. So I could say that the time is it has been, let's see, so if I look at it this way, and I've got my negative 25 over 444 plus 1/6, I'm going to end up with my 49 over 444. And so it will be the time between them, at what time is the distance between them at a minimum? So we could say at 49 over 4/44 of an hour after the eastbound plane took off. This doesn't really make sense based on what it says, but that's what it goes. From when we started the clock, I don't know. I don't know how we should best phrase this. But basically that's what's happened. That here's this plane flying this direction. So we could say, I know how we could say it. 49 over 444ths of an hour after the eastbound plane didn't start past Bangkok. Or we could say 25 over 4/44ths of an hour before. So here's how I'm accounting for my negative. So before plane 2 past Bangkok. All right. So that's how we can make sense of our negative there. If I had set this up as t and t minus 1/6, I would have ended up with a positive time, but plugging it in here still would have made a negative value. I don't say negative time though. I talk about before or after.